Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 11, Completing the Square. This is just one of many ways to factor a quadratic expression. Or equation. Classwork opening exercise. Rewrite the following perfect square quadratic expressions in standard form. Describe patterns in the coefficients for the factored form x plus a squared and the standard form x squared plus bx plus c. Okay, so we have a factored form right here. We want to write the factors and then distribute and find standard forms. All we're doing is the distributive property, or what a lot of people call FOIL. Okay, so example 1, x plus 1 squared. Now remember that when a quantity is squared, it just means something times itself. So when we want to write these factors, it would just be what is being squared. What is being squared, x plus 1, times itself. So these are the two factors of x plus 1 squared. It just means x plus 1 times x plus 1. Now it says to distribute. So if I multiply x times x, I get x squared. X times 1 is x. And we add them because there's pluses in between here. X, so we did the first, x times x. Outer, x times 1. Inner is 1 times x, which is also x. And then last, 1 times 1, which is 1. And then standard form is just going to take this and combine our middle term, and we're going to end up with x squared plus 2x plus 1. And that is the standard form with factors of x plus 1 squared. Okay, so see if you can do the rest of them. So pause the video, see if you get it, and then unpause the video and check your solutions after. All right, so now I'm going to do this. So all I'm doing is taking the factored form, which is x plus 2 squared, and saying it's x plus 2 times itself. Okay, and then I'm going to do the distributive property. X times x is x squared. X times 2 is 2x. 2 times x is 2x. And then finally 2 times 2 is 4. Combine my two middle terms, and that will give us the standard form of x squared plus 4x plus 4. So x plus 3 squared is simply x plus 3 times itself. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. So we get the combining of the like terms. This will give us x squared plus 3x plus 3x is 6x. And then plus 9. Okay, the next one. X plus 4 times itself are the factors. And then x times x is x squared plus x times 4 is 4x plus 4 times x, 4x plus 4 times 4, 16. Combining these like terms in the middle will yield x squared plus 8x plus 16. Hopefully you start to see a pattern here. Okay, next one. The factors are x plus 5 and x plus 5. Multiplying, we get x squared plus outer is x times 5, which is 5x. Inner is 5 times x, which is 5x. And 5 times 5 is 25. 5. Combining the middle terms will give me x squared plus 5x is 10x plus 25. And finally, the last one, x plus 20 squared is x plus 20 times x plus 20. Okay, and then x times x is x squared, plus x times 20 is 20x, plus 20 times x, which is 20x, and then the last are 20 times 20, which is 400. Okay, so that will give me x squared plus, adding the middle terms, 40x plus 400. So let's talk about the pattern that occurred here. If we have perfect squares, the constant here gets multiplied by 2 to give us our middle term, and it gets multiplied by itself to get us our last term. Whenever we only have a leading coefficient of 1. So 2 times 2 is 4, that gave us 4. 2 squared is also 4. But 3 times 2 is 6, 3 squared is 9. 4 times 2 is 8, 4 squared is 16. 5 times 2 is 10, 5 squared is 25. 20 times 2 is 40, 20 squared is 400. So all we're doing when we have perfect squares like this with a leading coefficient of 1 is doubling this number to get the middle term and squaring it to get the last term. Okay, so example, now try working backward. In other words, factor these. Rewrite the following standard form quadratic expression as a perfect square. So I'm going to first of all do this, because it says factored form. Actually, it doesn't say write the factor, so factored form is quantity squared. So let me just do it with one parenthesis. Okay, because if I go back up here, the factored form is something squared. So I know that I have an x squared, and I had an x squared here, so the first term has to be x times, because x times itself is x squared. But then I have to look at this last number here, 36, and ask myself, what's the square root of 36? Because remember I told you that if we have a perfect square, we just square this number to get this. So if we have this number, to get back to this number, we take the square root. And the square root of 36 is 6. And these are all pluses here and here. So I'm going to put a plus sign here. And check, is 6 times 2 12? If so, then we chose the right factor. So here's the factored form. So the square root of the last term, and it's the middle term divided by 2, going in the reverse direction. So now when I do this one, watch your signs though. We're going to have a minus sign here because of this minus sign here. Remember, a negative times a negative is positive, so that will give us a positive at the end here. The square root of 36 is 6, and 6 times 2 is 12, so this is x minus 6 squared. Because if we FOIL this, let me just show you on this case, x minus 6 times x minus 6, which is x minus 6 squared. When I do the first term, I get x squared. When I do the outer term, I get negative 6 times x, which is a minus 6x. The inner term is negative 6 times x, which is minus 6x. And then the last term is a negative times a negative, which is positive. 6 times 6 is 36. And when I add these two, I get x squared minus 12x plus 36. So whenever we have a minus and then a plus, we know that the factors are negatives. Okay, so I have a plus, I have a plus. That's the first thing I'm going to look at is the sign. So I'm going to do this, I'm going to put a squared symbol here, and I'm going to put this, a plus sign here when these are both positive. So I'm going to ask myself, this is definitely an x because the square root of x squared is x. The square root of 100 is 10, and 10 times 2 is 20. So this would be x plus 10 squared. Okay, this one, parentheses, squared symbol. We have a minus and then a plus, just like we did up here, so I know that this symbol here is minus. The sign is negative. Okay, so now I need to know what the square root of 9/4 is. Well, the square root of 9 is 3, and the square root of 4 is 2. So if I have x minus 3 halves times x minus 3 halves, is that going to give me 3? So 3 halves squared is 9/4, and 3 halves times 2 is 3. Okay, so don't let fractions scare you. Okay, next one. Parenthesis, parenthesis, squared. I have a plus, I have a plus, therefore I have a plus. I have an x squared, so that's x times itself. And the square root of 2,500 is what we need to know. What times itself is 2,500? Well, 5 times 5 is 25, so 50 times 50 is 2,500. And 50 times 2 gives us our middle term. Okay, hopefully this is getting easier for you. And then finally this, I would square, plus plus, plus, x squared, square root of x squared. And now we have x squared plus 8x plus 3. Well, now we're running into a problem because the square root of 3 is the square root of 3. And we don't generally put this here. Okay, so I just wanted to show you something here. So working backwards, remember we took the square root of 36 and got 6, the square root of 36, 6, the square root of 100, 10, square root of 9/4, 3 halves, square root of 2,500 is 50. The square root of 3 is the square root of 3. So just bear with me here. This isn't correct, but watch what's going to happen if I check this. If this was my answer, and I did the distributive property or FOIL, x times x is x squared, x times the square root of 3 is the square root of 3x, plus the square root of 3 times x is square root 3x, or x square root 3, and the square root of 3 times the square root of 3 is 3. And then that will give me x squared, and then when I add these, it would be plus 2 square root 3 times x plus 3. And obviously 2 square root 3 is not equal to 8. So this is incorrect. And for now we're just going to say it's not applicable to this setup because the square root of this does not equal this times 2. So we can't just simply find a perfect square of x squared plus 8x plus 3. So eventually we're going to be able to learn how to complete the square, because this just can't be done in this form. Okay, so here we are on to page 2, exploratory challenge. Now, since we couldn't find the perfect square, because we weren't given, there's no way to find a perfect square of this because the square root of 3 does not equal 2 times 8. I'm sorry, the square root, now let me go back and show you what I'm talking about here. So let's just pick one that is a perfect square. X plus 5 squared. So if we had x plus 5 quantity squared, that equaled x squared plus 10x plus 25. Because this squared is this. So in other words, the square root of this, the square root of 25 equals, let me rewrite that neater, the square root of 25. If I take the square root of this, I get 5. And then if I multiply that by 2, 2 times 5 is my middle term. And that's what we were trying to do. So I took the square root of 3 to show you that the square root of 3 times 2 does not equal 8. And I can prove that with a calculator. So if I do 2 square root 3, it should equal 8. If it doesn't, obviously it doesn't, it's only 3.464. It does not equal 8 when I multiply the square root of 3 by 2. So I can't just take the square root of this times 2. So what we have to ask ourselves here is, self, what does this number have to be to give us this? In other words, 8 divided by 2 is 4. 4 squared equals 16. This is 3. I need a 16 there to make that a perfect square. So I needed a 4 here, not 3. Does that make sense? So in order for this to be a perfect square, it had to say x squared plus 8x plus 16. And that would have given us x plus 4 squared. Because 4 squared is 16, and 4 times 2 is 8. But that's not what we have. We only have 3. So if we had x plus 4 squared, that would give us x squared plus 8x plus 16. That makes sense? And we only have x squared plus 8x plus 3. And we have a plus 16 here. Well, how do I make this last piece equal to 3? Well, if this whole thing is plus 16 and I only want 3, how much do I have to subtract from 16 to get it down to 3? I have to subtract 13. So actually it'd be x squared plus 8x plus 16 minus 13, which would be x squared plus 8x plus 3. So if this piece here equals this piece here, we also have to put minus 13 here to make it a perfect square, or a factor, an expression equivalent to this using a perfect square. Okay, so we'll get some practice here doing this. Actually, before I continue, I'm going to show you that this is true. So let's substitute a value in. So let x equal 5. So if I put 5 in here, that would be 5 squared plus 8 times 5 plus 16. And then I'd subtract 13 from that. That'd be 25 plus 40 plus 16 minus 13. 25 plus 40 is 65, plus 16 is 81, minus 13 is 68. If I plug in a 5 here, that would be 5 plus 4 squared minus 13, which is 9 squared minus 13. 81 minus 13 is 68. So it checks. So that concludes that x plus 4 squared minus 13, these two are equivalent, but would it work here as well? So then I'm going to take 5 squared plus 8 times 5 plus 3. And that would be 25 plus 40 plus 3. 40 plus 25 is 65, plus 3 is 68. So we got 68 from this, we got 68 from the factored form, and we've got 68 from this here, so that proves that this is equivalent to that. Okay? Alright, so let me just move this a little bit and slide this up. So now we have exercises. Rewrite each expression by completing the square. So the first thing we're going to do is I'm going to put an a here. It's minus plus, so I know that's a minus. And I'm going to close the parentheses and square it. In order to get 4 here, half of 4 is 2, and 2 squared is 4. So this would be 2. Okay, so let me not go too far from this. And let me get some of this checking out of the way. Okay, so notice what we did here. All I did was take half of my middle term, but then I have to figure out what I need to add or subtract to get my last term. So half of the middle term is minus 2. So if I distributed this or FOILed, I'd get a squared minus 4a, and negative 2 times negative 2 is positive 4. Positive 4 is not 15. What do I have to add to 4 to get to 15? And that is 11. So a minus 2 squared plus 11 is equal to this as a completed square. So what we're doing here is we're taking half of the middle term and squaring it. Okay, number 2. So I'm going to put a parenthesis. My first term is n squared, so it's n. I've got a minus and a minus here. Okay. Half of 2 is 1, so I'm going to put n minus 1 squared. N minus 1 times n minus 1, let me do this over here. N minus 1 times itself. When I distribute, I get n squared. Inner, I get minus n. Outer, I get minus 1 times n, which is another minus n, and a negative times a negative is positive 1. That would give me n squared minus 2n plus 1. I have n squared minus 2n minus 15. So what do I have to do to 1 to get down to negative 15? I have to subtract 16. Okay? Okay, so what we're doing in essence is taking half of that middle term and putting it here, but then we have to figure out what we have to do to that middle term to get this. So in other words, if I take this c squared plus 20c minus 40, then that is c squared plus 20c, and then I'm going to leave a space, and then I'm going to put minus 40 over here. Now what I need to do is make a perfect square, so I'm going to put a bracket here. And I need a perfect square in here, and half of this term, half of 20 is 10, right? So you take the middle term and divide it by 2, and that equals 10, and then you square it, and that goes there. 10 squared is 100. But I want minus 40, and I have c squared plus 20c plus 100 is my perfect square. So what do I have to do to finish this? Okay, well I added 100 to this centerpiece here, and I can't just simply add 100 to something because it's no longer going to be equal. But if I add 100 and subtract 100 at the same time, then those would cancel out in essence, and this is still going to be equivalent. So if I move this out of the way now, I now have a perfect square. So this is c plus the square root of 100 is 10. 10 times 2 is 20. So I put squared here. And then outside here is minus 40 minus 100, or minus 140. Okay. Hopefully this is getting clearer to you. A few more examples and maybe it'll be better. Okay, so here we go. I'm just going to rewrite this with a space because the square root of 60,000 is what? It's not a perfect square. If I take the square root of 6, if I get rid of all these zeros, the square root of 6 is not a perfect square. The square root of 60 is not a perfect square. Okay, so I need to rewrite this as x squared minus 1,000 x. And then there's going to be some value in here to make a perfect square. And then I'm going to put plus 60,000 out here. Okay, so what is 1/2 of 1,000? Half of negative 1,000 is negative 500. And if I square negative 500, negative times a negative is positive. And 5 times 5 is 25. And I had 2 zeros, so now I have 4. So it's 250,000. But if I added 250,000 to get this to be a perfect square, I have to subtract 250,000 over here. Okay, so let me move this out of the way. Why is that not working? Okay, there we go. So we have a perfect square now. We have x minus, because of this minus sign here, and 1/2 of 1,000 is 500. Quantity squared, that is this as a perfect square factored, because 500 squared is 250,000. But then I have this plus 60,000 minus 250,000, so it ends up being minus 190,000 outside of my parentheses. So this is equivalent to this here. Okay, on to page 3, number 5. Y squared minus 3y plus 10. So the square root of 10 is not a perfect square. So I can't take half of it and get negative 3. So what I'm going to do is rewrite this as y squared minus 3y, and I'm going to put that in a bracket like this. So I'm looking for a perfect square here, and then plus 10 is just going to be hanging out over here for a minute. So half of negative 3 is negative 3 over 2. Let me do this off to the side so I don't have to erase it. So we're taking half of our middle term, negative 3 divided by 2, and then we're squaring it, which equals a negative 3 times a negative 3 is positive 9, and a 2 times 2 is a positive 4. So that squared is 9/4. So that's plus 9 over 4. Well, if I add 9/4 here, I have to subtract 9/4 here, because 9/4 minus 9/4 is nothing, and therefore that's still equivalent to y squared minus 3y plus 10. 9/4 positive and negative thrown in there does not change the value, if that makes sense to you. Hopefully it does. So now we take the square root of y, and we take the square root of 9/4, and we take this sign. So it's minus 3/2. So we take the number that we squared, and that is our factor. So it's y minus 3/2, quantity squared, and then 10 minus 9/4. Well, 10 is 40/4, right? Multiply this by 4 over 4, we get 40/4, minus 9/4 would be 31 over 4. So there's our answer. Okay. Number 6. First thing I'm going to do is write k squared plus 7k. I'm going to put this in a bracket and leave a space for my final term and put the constant plus 6 outside here. Okay? I'm going to take 7, which is my middle term, and divide it by 2. Take half of it and square it, and that's going to equal 49, 7 squared over 2 squared, which is 4. So that's going to be plus 49 over 4. But to keep this expression the same, I now have to subtract 49 over 4 from my constant term. So now I'm going to get k plus something squared. Well, it's this middle term here that we squared, 7/2. And now I need to take 6 minus 49/4. Well, in order to subtract fractions, our denominator has to be the same, so I need to get 6 to be something over 4. Well, what is 6 times 4? It is 24 over 4. 24 divided by 4 is 6. Now I can take 49/4 minus 24/4. Is that right? No, it's the other way around. We are taking 6, which is 24/4, minus 49 over 4. And that's going to equal 24 minus 49. Okay, I'm just going to be careful here. Use a calculator. 24 minus 49 equals a negative 25. So it's going to be negative 25 over 4. So this is minus 25 over 4. So this is our answer. Okay, number 7. First thing I'm going to do is rewrite it. Z squared minus 0.2z. Leave a space and put a bracket. Put our plus 1.5 outside. Half of negative 0.2. So we take half of negative 0.2, in other words, divide it by 2, and that equals negative 0.1. So that's going to be z minus 0.1 squared, but I need to know what that is squared. So now I want to square this. Well, 0.1 times 0.1 is, and let's be careful here, and I'm going to show you that a negative times a negative is positive, negative 0.1 squared equals 0.01, because we have 2 decimal places. So that's going to equal a positive 0.01. So we're going to add, this is going to be plus 0.01 plus 0.01. I'm not plus, minus here. If we're adding 0.01 to the inside, right here, we need to subtract 0.01 from out here. So I get z minus 0.01 squared, and then 1.5 minus 0.01 is plus 1.49. 1.5 minus 1/100th. Think of that as 1.50 minus 0.01, and we borrow from the 5 and we get 4, and that's 941. So that's where the 149 came from. Okay, so this is the completed square factor. Number 8. First I rewrite it, p squared plus 0.5p, leave a space, put a bracket. Add 0.01 outside. Take half of the middle term, 0.5 divided by 2 equals 0.25. I'm going to square that, which equals 0.25 times 0.25 is 0.625, 0.0625, 4 decimal places, 0.0625. So I'm going to be plus 0.0625, and since I added that to this, now it's no longer equal to this, but I have to subtract 0.0625 from that side, and then when I take the perfect square of this, it's going to p plus, it's going to be p plus my half of my middle term, 0.25 squared, and then 0.1 minus 0.0625. So that'd be 0.1000 minus 0.0625 without using the calculator, and I get 9, 9, 10, 5, 7, 3, 0.0375. So it's plus 0.0375. And that is my answer. Okay, number 9. Hopefully this is getting easier for you. Whenever there's a procedure that you repeat over and over, it should get easier. So I'm just rewriting j squared minus 3/4 j. Put a bracket here, put a bracket here, and put plus 3/4 outside. Then off to the side here, I want to take negative 3/4 and divide it by 2. Be careful with fractions. Negative 3 over 4 divided by 2 over 1, remember, is equal to negative 3 over 4 times the reciprocal of 2 over 1, or 1/2, which is negative 3 over 8. So half of negative 3/4 is negative 3/8, and then I square that. So I now have j, not squared, j, I'm looking for the perfect square of this here. Let me finish this before I go, though, over to that. So negative 3/8 squared is negative 3 squared, which is 9, and 8 squared, which is 64, 9/64. All right, so that is going to be plus 9 over 64, and then I need to subtract that same 9/64 outside. So j, my answer is whatever's in parentheses over here. What is half of my middle term? It's going to be j minus 3/8 squared, and then 3/4 minus 69, or 9/64. All right, so I need common denominators. So 4 goes into 4 once, for the remainder of 2, and 4 goes into 24 6 times. So it's 16. I need to multiply this term by 16 over 16, right? 3 over 4 times 16 over 16 would give me 6 times 4 is 24. Carry the 2, 4, 5, 6. That gives me a denominator of 64, which is what I need. 16 times 3, 6 times 3 is 18. Carry the 1. 3 times 1 is 3, plus 1 is 4. So 3/4 is equal to 48/64. So I'm taking 48 over 64, which is right here, and I'm subtracting 9 over 64. And that is going to give me a denominator of 64, and 48 minus 9 is 39. So my answer is plus 39/64. So it's j minus 3/8 squared plus 39/64. Okay, last one on this page. Let me get this out of the way. Okay, so here we go. X squared, so this is in general, because it's x, b, c. So it's ax squared plus bx plus c, where a is 1. So we have x squared minus bx, leave a space, plus c. And this is going to give us our general formula for completing a square. So I want to take half of b, so I take negative b, the middle term, and divide it by 2. And then I square that. And that's going to be negative b times negative b is positive b squared over 2 squared, which is 4. So this is going to be plus b squared over 4, but then we also have to subtract b squared over 4. And that will give us the perfect square of x minus what we have in parentheses, b over 2 squared plus c minus b squared over 4. And this, my friends, is the formula for completing the square. Okay, page 4. This is the end of lesson 11. Review the lesson summary and go do your problem set.